Hello there, and welcome back to Hydroponics Daily, your go-to podcast for everything soilless cultivation. I'm your host, Dr. Russell Sharp. Today has been a bit of a strange day. We spend hundreds and hundreds of pounds on Google ads and Facebook ads. We didn't get a single order for any hydroponic fertilizer or biostimulants this morning, and then in the afternoon it just went mad. I don't know what Google and Facebook were doing, but it was weird. We had a really good day in the end, but nobody ordered any. It must have been Monday morning blues. Everyone had the Monday morning blues after such a lovely weekend. But yeah, I'm happy again now. The orders have rolled in for gold leaf, or liquid gold as we call it in the UK, and all our other biostimulants. And so I thought I'd jump on and record a podcast about something upbeat and cheerful. And what could be more upbeat and cheerful than growing peas, beans, mange too, and other legumes in hydroponics? And yesterday we talked about growing potatoes in hydroponics, and it's not the sort of crop that springs to mind immediately. It's, let's grow potatoes. Yeah, everyone gets excited. But there were lots of reasons why you could potentially and would want to grow potatoes. And the same for legumes. It's not the first crop that comes to mind, often because they're grown on vines, and that's an added complexity when you talk about hydroponics. And also you've got beneficial microbes that are essential for the growth of legumes. And that adds an extra complexity when it comes to hydroponics. But where there's complexities and challenges, there are niches that specialists can take advantage of. And there are some high value legume crops out there if you can find them. They might not even be food crops. They might be non-food crops. They might be bioherbicides you can extract from them, pharmaceuticals. There are, these things exist in legumes. What else is in legumes? Oh, from the roots of soya beans, you get the legume compound, which goes into the is it Impossible Burger or one of them, the plant-based burgers and meats, the red juice that comes out when you cook those plant-based meats. That's from the roots of the soya bean, because they need a oxygen scavenging molecule to keep away from the bacteria. And that's why legumes contain a type of heme product, like hemoglobin, because the bacteria are anaerobic, I think, so they don't want oxygen. You can tell I've not researched this properly this episode. I'm just spitballing and going off the cuff. But yeah, so there's loads of different compounds in legumes. They're a really interesting plant family. There are lots of toxins in some of them as well, so you have to be careful. And things like lupins can be highly toxic to certain animals, and other plants can eat them. Other things can eat them, like snails, eat them without getting poisoned. But rabbits, they're toxic to rabbits and deer and things like this. So loads of interesting, a really diverse plant family, with some plants that can be grown on their own with no support, like lupins, and you can get edible lupins, through to things like mange too, which need a support system. So we'll talk about that, and we'll talk about how you're going to grow them hydroponically. There are some commercial legume growers, not massive though in hydroponics at the moment. I think it could be one that takes off. We'll talk about fertilizing them, because the fertilizing will be radically different to normal hydroponics. So let's dive in. So are legumes hydroponically viable? Legumes such as peas, beans, and faba beans can be absolutely grown hydroponically. Systems like NFT, DWC, vertical farms have successfully produced the pods for human consumption, but also for fodder production. And legumes are really important when it comes to animal feed, because they're a source of plant-based protein. So around here, in the fields around my village, there are loads of beans being grown. That's all for animal production. And in the UK, there's big interest in getting a lot more farmers growing peas and beans, because we import legume crops from like America, and there's a big carbon footprint from doing this, and it's also not food security. So we're looking for more fodder legume production in the UK. So could hydroponics supply that? And there's a lot of interest in hydroponics for fodder supply and food for animals. And so yeah, potentially. So there's a lot of interest in the UK in growing haricot beans for baked bean production. In the UK, we eat an awful lot of baked beans, and yet we don't produce any of the beans that go into baked beans. So there are a number of farmers, plant breeders, technicians, food production companies that are looking to produce baked beans in the UK. Could hydroponics help with that? So you'll see companies like Fork Farms in Wisconsin that are growing peas and beans in their Flex Farm system, and they've shown good success in their sort of almost commercial scale systems. I don't think they're quite like large scale. You'll see lots of growers on Reddit also confirming that they've been able to grow peas and beans and mange too. There's a company called Gyroplant in the UK, and they make the little cups that go into NFT and DWC systems. And they've also grown hydroponic legumes sustainably and all year round. So they're based in Didcot. Shout out to Didcot. And at the Rutherford Laboratory, which is like a physics laboratory, like particle physics laboratory. I don't know how they came out of that. There must be some crazy science involved in their little Gyroplant cups. And then research on faba bean production has been done in Palestine, in the Palestinian territories. And that was really interesting, that study, because they were looking at treated water, so desalinated water, to see if they could grow the crops. Now, faba beans are a big staple in that region, and desalinization is a big issue. Now, one of the key things when it comes to growing legumes is most species are extremely intolerant of salt in the system, because the bacteria that support the nitrogen fixation, which is a key part of growing beans, they die when exposed to lots of salt. So these trials in Palestine were looking at what level they could grow them successfully, and it was found that flowering and fruiting were the limiting factor. You could get a crop with fairly saline water, but the flower, it wouldn't flower. So that's really important. Really good research that was done there. When I think of faba beans, though, I always think of Silence of the Lambs and Hannibal Lecter, that famous line. I'm not going to recreate it because I can't do it justice. But yeah. Anyway, fertilizer requirements. So unlike soil-grown legumes, hydroponic legumes normally receive nitrogen directly from the nutrient solution, because the biological nitrogen, no one's been able to optimize nitrogen fixation in them. Studies show that even with rhizobia, the bacteria that normally fix nitrogen for legume plants, nitrogen levels often need supplementing to meet growth targets. So that's different to, say, in a soil. In a farm situation, the farmer doesn't add any nitrogen to the field on the year that they're growing a bean crop. And whereas you can add nitrogen, but it's a waste, because you can normally just rely on the bacteria to do that. Now, some farms, they would also add a rhizobium inoculum, especially in regions where the soil's been sterilized or it's never grown beans before. And if you've grown hydroponically, you might want to try the addition of these rhizobia that fix nitrogen from the air or the soil air and make it into a source that's available to the plant. A good source of those would be Legume Technologies in Nottingham in the UK. I've been to their facility and we've worked with them on a number of bacterial products. They've got really good products. We don't work with them anymore because they can't supply us 12 months a year, just because they are working so much on rhizobia for soybean and other legume crops. So I would definitely look at a with and without for a rhizobia, and a with or without nitrogen if I was ever going to be messing around growing legumes hydroponically. That would be essential. A lot of people who've grown hydroponic legumes as well will have added nitrogen, because the off-the-shelf hydroponic fertilizers will contain a lot of nitrogen, and you're not going to be able to get a company to make them without nitrogen. And the same for the recipes that you'll find for even experimental hydroponics. They will always contain nitrogen because they're designed for other plants. If somebody wanted to set up a hydroponic system that was lacking in nitrogen to test whether it could be done and grow legumes without nitrogen in hydroponics, then give me an email. I would be happy to create a bespoke legume fertilizer for hydroponics that was lacking in nitrogen. I think that would be really interesting. So if anyone has got the ability to set up that trial and wants some nitrogen-less fertilizer, maybe gold leaf or liquid gold as it's called in the UK, without nitrogen, then hit me up and I'll see if we can supply that. That'd be really interesting to do that. Every other nutrient would have to be supplied in the fertigation solution. So legumes can't fix anything else out of the air. There's nothing else in the air apart from carbon dioxide, and water that they could actually use. So, phosphorus, potassium, calcium, magnesium, all the micronutrients, iron, example, they would all need to be in the right amounts. It'd be interesting to know what would happen about the pH as well without that nitrogen there. So that'd be really interesting. So the rhizobium question could potentially help reduce the nitrogen use. How much, we don't know. The problem is if you have bacteria in your roots and then you get algae, normally what you would do is when you get algae, you sterilize the system with something like hydrogen peroxide. However, you would damage the microbes in the plant roots if you sterilize the root system. So there's another added complication. As I said, the rhizobia are anaerobic. That's why they've got these heme pigments in there, and they need sugars. So you could struggle with the sort of oxygen levels, the high oxygen levels. I don't know. It's worth it looking at. So if you've sort of skipped over the fact that legumes have nodules on their roots, if you're looking for a healthy legume plant, there will be if you dig them up, you'll see lots of nodules, and then you can stain these to see if they contain the bacteria. The nodules are also a host. They also host mycorrhiza as well. So you could add mycorrhiza into the system, and they will be helping with the absorption of phosphorus, not fixing of phosphorus, but the absorption of phosphorus. So that'd be interesting. Legumes are not the only plants that fix nitrogen. Things like alder also fix nitrogen. They'll have nodules on their roots. Lots of plants have nitrogen-fixing bacteria associated with their roots, but legumes are the best at doing it, and they absorb the most amount of nitrogen, and they're probably the only food crop that does it. So one of the misconceptions is that if you grow a legume crop, you don't need to add nitrogen the next year because the roots that are left there will contain loads of nitrogen. And it's not true, because all the nitrogen is going into the pods to fill these peas and these beans and these mange tout full of protein. The nitrogen goes into amino acids, and the amino acids go into protein. So once you've harvested all that protein, there's not much nitrogen left. So don't think that you can add loads of nitrogen by doing that. The only way you would do that in a soil-based system is by adding a legume green manure and then digging it in before it flowers and fruits. So what else can we say? You might want to inoculate your seed with the rhizobium and the mycorrhiza before you sow them, and obviously gentle aeration, not too much. Other interesting notes: some people have looked at cereal legume co-cultivation in various systems. You can do something called boats, what is boats? Is that barley and oat? No, not beans and oats are boats. Beans and oats, boats. I've seen that being grown here, just a few fields away from where I am now. You might want to look at the photoperiod, similar to other fruiting sprouts, around 16 hours for flowering and pod development. So these are long day plants as opposed to short day plants like hemp and hops. What system would I choose if I was going to grow legumes? I'd probably go NFT. DWC would be, I wouldn't start off with DWC. It might be good, but I'd look at that later on. So yeah, and I might also look at, rather than going for peas, beans, or legumes, or chickpeas would be a good one to look at because they don't require support. But if I was going to grow anything first time, it would probably be edible lupins because they're an unusual, bespoke, niche crop that you could get high value for. You could almost have like a superfood. And also the beauty of that is that they're big plants, but they support themselves. So you could get a lot off and then double lupin without having to have support. Whereas chickpeas, they are more for like marginal land in like Africa and places like that, where in Asia, where they don't grow, they'll grow in very low water levels. They'll produce a harvest, but they're not going to produce bumper yields. Whereas a lupin, they grow like, crazy. And also lupins are fairly resistant to mildew. They will get it though, because the water bounces off their leaves. They've got like this weird, they're not waxy leaves, but they've got loads of hairs on them. And the hairs are hydrophobic and the water just bounces off. The good news is that when you do get mildew on lupins, you can treat them with chitosan really easily. And it's one of the great examples we've used in the past to show how chitosan works as a biofungicide, because it doesn't stick to where the healthy leaves, it only sticks to the damaged leaf. It's really cool. So that's something to look at. And also, there's loads of interest in pea proteins and legume proteins from not just a vegetarian, vegan, meat alternative perspective, just in alternative foods and food development, food science, looking at ways of incorporating different proteins and what can be done with plants. So if you think of a huel, not gruel, huel, that is a pea protein based meal replacement, whatever. So there's lots of interest in pea proteins. So combining all that vegan science, that alternative meat science and hydroponics and vertical farming, you can get a lot of investment from the City of London or Wall Street if you set up a hydroponic pea protein. Wouldn't have to make any money. You just have to get investment. That's the key, isn't it, really? As I say, pea is very, very intolerant of salt stress. So I would definitely do a dose response curve, looking at nutrient levels, because some of the higher dose levels recommended by some hydroponic fertilizer companies would just be way too much. One plant species that is a legume that is tolerant of high salt levels is tree lupin. And so if you could breed in the salt tolerance from tree lupin into the other species, that might be something that you could look at for hydroponics. That'd be interesting. And then you would also need, and this is one of the key factors, I can't believe I've missed it, is you would need to have good pollinators in your grow environment, because peas would require pollination to set good fruit sets. So you want the actual pea, the beans, the seeds, the faba beans, the Monge 2, then you would need bumblebees or some other pollinator in your grow environment that could pollinate those flowers. Probably going to be a bee of some sort because of the shape of the flowers. I think they're almost certainly bee pollinated. You couldn't have a moth or a butterfly or anything like that, or maybe a hoverfly potentially, maybe even a blue bottle. Companies like BioBest that sell bumblebee sets, houses, hotels, something like that that you can put into your grow environment. You'd almost certainly need one of those. I have seen some growers who buy a pack of maggots from the fishing tackle shops and then just wait for the blue bottles to emerge and then allow the blue bottles to pollinate. They're not as good as bumblebees, but they are a lot cheaper. So you could do an experiment. You could have one greenhouse with bumblebees and you could have one greenhouse with maggots and blue bottles. Interestingly, I think Copper have just released hoverfly larvae as a biocontrol agent for aphids. And when they metamorphosize into the actual hoverfly, they would also be a really good pollinator. So that would be an interesting one. Could you control the aphids on your legumes with hoverfly larvae and then also allow them to complete their life cycle and form hoverflies that could pollinate? I'll probably stop this podcast now and see if hoverflies can pollinate a legume. And I'll sound really clever when I come up with the answer in 1 second's time. Yes, hoverflies can pollinate legumes. So I wasn't on a stupid tangent there. So that's a wrap for today's episode on legumes in hydroponics. If you're interested in integrating peas and beans into your setup, if you're a commercial setup and you're looking to look at that, and if you're looking for a hydroponic fertilizer that lacks nitrogen, get in touch with me and we can set up an experiment and some potential formulations for that. I'd be really interested in doing that. If you're a grower who's looking at legumes and you've been shared this podcast episode, then you owe the person who shared it with you a drink. And if you could also do me a favor and screenshot your podcast provider on your phone and share it to social media and say, this was an amazing episode, or check out Hydroponics Daily. That would be great as we spread the word and try and grow our listenership in other countries. Where are peas and beans grown most in the world? Where am I going to get loads of listeners for this episode? I don't know. I said chickpeas, Africa. Lupins are a weed in New Zealand. I know that. Monge 2, I would imagine that's France, isn't it, with a name like that? Or it might be Peckham in London, because that was a famous quote from a comedian in a famous sitcom in the UK, Only Fools and Horses. Monge 2, Del Boy, Monge 2. Yeah, if you know where there's loads of legumes grown, then let me know. There are lots of villages in the UK called things like Barton in the Beans and other strange village names, where I guess traditionally they've grown loads of legumes. But yeah, come on, guys, let's set up some hydroponic legume farms. I think it's a really interesting topic and definitely one I hope to revisit in the future when some of you set up some commercial farms doing some really interesting things and extracting some really interesting compounds and foodstuffs from there. Until tomorrow, that's been Hydroponics Daily. Thank you very much.